Now we'll do a second example in input quantization error. So consider, the question goes like this: consider the recursive filter with input x of n. Recursive filter shown in the diagram. I will draw the diagram below, shown below. Input x of n as a value ranging plus or minus 100 volts, okay, which is represented by 8 bits. Compute the noise, okay, compute the variance, it is also called as steady state output noise, okay, of output due to ADC means it is called quantization, okay, that's what they mean, okay. And the question they are given, the system, the recursive filter looks like this. So they have given the error and y of n is given, and they have shown a simple signal flow graph, and here it is Z inverse, okay. So this is what they have given in the question. So first thing, we have to interpret information given in the question. So they have given the range of the signal is from h of n as a range of plus or minus 100 volts, which means that the dynamic range of the signal is 100 minus 100, which is nothing but 200 volts. It is the dynamic range of the signal that is given, okay. So number of bits that was used to represent, it is also given. It is 8 bits have been used to represent, okay. So with this information, okay, and one more information is given. From this diagram you can easily draw what is the difference equation, okay. See here, one side of it, y of n is equal to, so this y of n is taken, it is delayed, so it is y of n minus 1, it is multiplied by 0.8 and it is added to h of n. So this is my first order difference equation is given. For this equation we know that it is similar to last time we have solved it for A, okay. So if you actually take Z transform for this equation, y of z equal to 0.8 Z inverse y of z plus h of z, and you find the system function y of z by h of z, it will be 1 by 1 minus 0.8 Z inverse, okay, or in other words h of z is 1 by 1 minus 0.8 Z inverse. From this we can tell h of n is equal to 0.8 power n u of n, okay. All these are the information that is given from question, that is the interpretation we do from the question, okay. Now we will go into the actual problem solving. We are solving still, but we are going to go into steps, okay. So this is our first step. So we interpreted what are the information in the question, and we also have found the value of h of n, okay. Now the third step is you need to measure what is the quantization step size, because here more information is given, okay. So quantization step size q is given by, okay, dynamic range is the formula by number of quantization levels, okay. So dynamic range is 200 by, it is 8 bit is used to represent, so it is 2 4 8. You divide this, you get 0.6 78125. That is my Q value. Okay. Now once I know the Q value, I have to find the variance due to input. Sigma E square is given by Q square by 12 or 0.78125 whole square by 12. So which gives you 0.05086. Okay. Once I know this thing, I can go to the next step to compute the variance due to output. So variance due to output is given by sigma E square into summation n equal to 0 to infinity h square of n. Okay. So sigma E square we have computed already, 0.05086 into summation n equal to 0 to infinity h of n is 0.8 power n u of n whole square. Okay. Now this u of n is having a magnitude 1 and 0 to infinity, so we can remove that. 0.86 into the summation value will become 1 by 1 minus 0.8 whole square. Okay. So this is, if you evaluate this value, it comes to 0.14128. Okay. So this is my steady state variance due to output. Okay. These are the 5 steps we use here to compute the steady state output. Okay. Thank you.